2 examples we did yesterday, okay? Do you guys remember when I was talking about the AP test, right? How they would test us as far as multiple choice questions, etc. I mentioned that they might give us Roman numeral 1 series, Roman numeral 2 series, Roman numeral 3 series. Which of the following converge, right? Okay. Does this one, would you answer that this one converges? Yes. Why? Conditions 1 and 2 are met. It converges. Would you answer that this one converges? Yes. Conditions 1 and 2 are met. Wait, you didn't do those, but why? But still, does this converge? Yeah. But wait, this one's conditional, this one's absolute. It doesn't matter if it was a which of these converge. They both converge because they both would meet conditions 1 and 2 of alternating series. Are the terms decreasing? The terms, not the alternator. Remember we looked at that yesterday? The terms apart from the alternator. Do the terms decrease regardless of sign? Yes. And the limit of the sequence of terms, does it go to 0? Yes. And technically, once again, that would be regardless of sign. I didn't change that one. Sorry, I changed the other one. Because both of them in your forever card are a sub n, which is apart from the alternator, right? Okay. Okay. So you would answer both of these converge? True. What if they asked you for more information? Okay. Let me try to think of an example real quick. Okay. Here's an example. Ready? Aryan, are you an American? Would you add to that at all, as far as your heritage? What would you say? Okay. True. Maggie, are you an American? Okay, could you qualify that any farther? What would you say? But you're an American too, right? So if I was to ask, are Maggie and Aryan, are they both Americans? Yes. Do you both have U.S. passports? Okay. They both have them, but their heritage is different. They're qualifiers. They would have extra characteristics. Now, is that perfect comparison to this? No, but it's similar. They both converge. But how or why or where did that convergence come from? Hey, this is actually a better comparison than I thought. Sweet, go team. Every now and then, natural genius. So, not literally, it just happened. Oh, you should have seen me period 1. Coming back. My computer was dying and the board and we were There's definitely just a random prayer thrown out in that one. Coming back. Wait. So I said they were both American, but I asked them both where they came from. Basically, right? They both converge, but where does that convergence come from? Ready? Conditionally means the convergence came from the alternator making it converge. This one, the convergence came from just the nature of the sequence. Who cares about the alternator? Okay? This one, the convergence came from the alternator. Without the negative 1 to the n, it would not have happened. This one came from, I don't care about the negative 1. 1 over to the n to the 4th is fine. So why did I not test? Now, that's just a strategy. Remember in our notes, remember there were these strategies we didn't really fill in? Oh, right here. Right here. I was like, okay, there are strategies, but we just kind of got to practice. You could test every single series for absolute convergence first. Some will pass. Oh, you're done. Absolutely converge. I don't need to do anything else. Some will fail. Well, it's not absolutely convergent, but what could it still be? Conditionally, so you'd have to go check your steps 1 and 2 for alternating series anyway. Or you could, well, actually, I would probably do this first no matter what. Anyway, I would do this one first no matter what. But sometimes it might be helpful to test for absolute convergence first, or test the alternating series first, which that's what you guys were looking at your forever card, which is steps 1 and 2, right? Okay, so you can either look at, ignore the alternator, does it converge? If so, absolute. If not, stink. Go check steps 1 and 2. Or start with steps 1 and 2 and then say, yay, it converges, at least conditionally. We have to go see if it's absolute. Aryan, go ahead.
Is there ever a scenario in which the alternator will make the equation which you not converge? Like, and where it's like if you did tested an absolute function and it converges, but then with the alternator.
Absolute convergence denotes that the alternator. Absolute convergence always proves that The series will converge with or without the alternator.
So an alternator can't make it.
Right. No. If anything, the alternator just helps it converge. It doesn't ever help it diverge. Or make it diverge. Okay. So with that, do you guys see me? And maybe I should actually do 1 and 2. I think that would be helpful. Pass 1, pass 2, converges conditionally. Why didn't I say absolutely? It's right here. Because disregard the alternator, it diverges from P series. P is equal to 1/2. Coming down here. This one. Where's my steps 1 and 2? I said, no, n to the 4th. I like him. This one, I was like, n to the 4th. I like him. He's fine. I don't care about the alternator. If the alternator just helps it converge, it already converges. I'm good. Yay, absolute value. Guess what? This converges no matter what. Therefore, absolute convergence done. I didn't have to do steps 1 and 2, but I could have. So then when you guys were trying this one, well, hold on. I know. They're working. Whisper. I fully support, but whisper. Okay, when you guys look at this one, is anybody looking here and saying, I'm not sure if he would converge if there wasn't an alternator? Is anybody looking at that? Why am I like, I'm not sure? Because if I compare it to n to the 1/2, doesn't n to the 1/2 diverge? Now, could I do a direct? Could I do a limit? But I think I could compare. I think this diverges, which means, should I do absolute value right now? No, because all I know is it's not absolute, I don't think. So let's go ahead and try steps 1 and 2. Step 1 says take the limit as n goes to infinity of, ignore the alternator. Does this go to 0? Yes, bottom wins. Try step 2. Are my terms decreasing? Here's one way of doing it. Plug in n plus 1. n plus 1 plus 3 would be, is this going to be always lower than or equal to? Why is this true? Isn't that a bigger denominator, which means a smaller number? Does that kind of make sense? You could write out the terms, and you could be like, yay, they're going down. Or you could actually plug in n plus 1 and be like, of course it's going to be smaller. The denominator's bigger. Either way, I know this converges, but how? Because if I was to test, limit comparison, totally. Because I don't want to deal with, is it always bigger, always smaller, always bleh. I don't like it. But that's okay, and if you do like it, have fun. But otherwise, I'm going to compare to 1 over square root of n, which diverges P equals 1/2. Are we good? P series test? So when I compare with the limit comparison, limit as n goes to infinity of 1 over square root of n plus 3, why am I comparing it to this? Because the limit is 1, which is greater than 0. So what one does, the other does, right? I love limits equaling constants. If it's infinity, better be divergent. If it's 0, better be convergent. But if it equals a number, sweet. So what does this do? This diverges. So since without the alternator this guy diverges, okay, then this is what kind of convergence? You want to try again? Okay, ready, set, go. And play with it. Sometimes absolute's easier to test for first, sometimes conditional. Does that make sense? Still working on it? But it's just like what to do, what to test first. Okay. That's helping, not distracting? Okay. Okay.
I mean, a divergence test, because it's going to equal 1. We can take the limit, right? Yeah, because it's n plus 1 over n. So then it diverges because it does equal 0. I mean, right? Yeah. Why am I so confused?
So it diverges.
So because it diverges.
So now we have to check the limit.
Wow.
So we did the nth term test on the absolute, which would be n plus.
Whoa. What happens if it doesn't equal 0?
And then so the limit as
Test
this
doesn't
goes
pass.
to infinity equals 1. So that means it diverges, right? So that means this
Test doesn't fail.
divergent.
Condition fails. What does your forever card say?
So now we or conditionally conditioned.
Test doesn't fail. Condition fails.
So then it diverges? Yes!
Wait, what?
Alright, you got it.
In order for the alternator to converge, those steps have to be true. So if one of the steps is false,
Step 1,
diverge.
limit equals 1, which doesn't equal 0. So then this fails, because in the card it says the limit as n goes to infinity has to equal 0, because it doesn't. It diverges
If you always started with the divergence test and then
Right.
you got it equal to infinity, that would just
Right.
prove the whole
Nth term test works for alternators. Because nth term doesn't have to be positive terms, so it can work for an alternating series. So you can always start with the nth term test.
mind blown. Oh my gosh, that's so convenient. Wow.
Did you hear that?
So you compare it to 1 over square root
Yeah, I love that.
and that diverges.
Number 7.
So then you use the limit comparison, so you divide it, and then since it's greater than 0,
That is 0.
then it diverges.
Mm-hmm.
So if it's
Because limit comparison test says as long as the limit is a constant, not 0, not infinity. What one does, the other does. So since the absolute value, forget the alternator, diverged, only conditional.
so if it were to converge,
Absolute.
then okay.
Oh, sorry, and this converged?
Yeah, well, if it were to converge and then it was
So it does converge
constant,
conditionally?
then the first one also converges. So basically the
Limit comparison test is gorgeous if it's a constant. What one does, the other does, no qualifications.
So
Or no restrictions. Yeah. Yeah, I love the limit comparison test.
Me too, I just got it.
oh wait, Maggie, can I see your forever card? So we're going to let you test. Right here. So first, since we know, so we did the absolute first. So we did the limit is 1 over n, and so it was 0. So that's the first one is checked. And then we have this one, and then so since 1 over n is greater
Now I'm
than
feeling confident.
1 over n plus 1, both tests. So condition. Does that make sense?
Well, there's another forever card. We just haven't gotten it.
That's the next lesson.
Oh my god.
Okay.
Okay.
They might get mad at you because of Guatemala, but hopefully not.
That's what I put
Try it.
I know, when I did
Yeah.
it, because I did it like a couple months ago.
Oh, and they let you do it?
Yeah, I said I went to Guatemala.
Yeah,
They said,
because
did you get your shot?
by itself, so if you took away the alternative,
Nice.
like just this,
I think I got
or
my
if you
shot.
tested the conversion,
Okay, they didn't use my blood card for my head.
n equals 1 of 1 over n. This would be divergence, right? Because B series, because it equals 1. So this, so then it's not absolute, because if it doesn't diverge by itself, then it's conditional. Yeah, does that make sense?
Hey guys, really quickly, can I talk about number 6 just real fast? Just real fast. Do you see me doing steps 1 and 2? No. Do you see me doing absolute value? No. What did I? If you look back at the divergence test, the nth term test, does it say only positive terms? No. It just says if the limit is not 0, diverge, done. But why did I say, pause, why did I say the limit does not exist? Out of the whole thing, I technically did the nth term test from the very beginning with the whole thing. Why do I have to say DNE and I can't say 1? Degree is tied. The ratio of leading coefficients is 1, but what is still in there? Negative, positive, negative, positive, negative, positive. So what am I going towards? Positive 1, 1 second, negative 1 the next second. Positive 1, negative 1, positive 1, negative 1. So what does the limit exist? Nothing. It can't make up its mind. But hold on, how else could you have gotten the exact same diverge conclusion? What if you had done step 1? What if you had done another way? Not the nth term test, but what if you did the alternating series test? Limit as n goes to infinity of just n plus 1 over n. Remember, alternator doesn't matter. What is it not? Diverge. The alternating series test says take an alternator. If steps 1 and 2 are true, converge. If either of them fail, diverge. Does that make sense? So either way, this first step failing, series diverges by the alternating series test. Oops, sorry. Or nth term test, the limit not equaling 0 diverges. So either way I get divergence. Does that make sense, kind of? Okay. So one's alternating series test, diverge, one's nth term test, diverge. All right, some of you are already playing. I'm going to give 30 more seconds on number 7. Did we already do this one? I feel like we did.
Could I ask a quick question while we're waiting?
Yeah.
For number 5,
Mhm.
I'm still like, I get it. I get how to do it now. But could you explain the math behind why the alternator makes it converge conditionally? Like, I don't get how multiplying by -1 makes it converge.
Multiplying by -1 raised to a power, an alternating power, an even odd power. It's the idea of it's the idea of positive negatives going to 0 in general, not addition, not series, just positive negatives going to 0 of a sequence will converge, whereas positive negatives going to any constant will diverge. Similar along those lines. So it's not just like a 1 over n that's adding every single time and accumulating, which the 1 over n squared, I still go back to improper integrals to try to make some sense of it. But the 1 over n isn't just addition now. Now it's subtraction. So stuff's being taken away every other. In my mind, that makes sense.
Okay.
As far as remembering, that's not a mathematical proof. There you go. Number 7. Bloop, bloop, bloop. I'm just going to start playing. Why might you not go looking for absolute convergence right away? Yeah, if you ignore him, 1 over n that diverges. Well, it's not absolutely convergent, but what could it still be? So I'm going to test 1 and 2. So limit as n goes to infinity of, and then will 1 over n plus 1 always be less than or equal to 1 over n? Yeah. So therefore, since n equals 1 to infinity of 1 over n, which is the absolute value, right, diverges, p series, p is equal to 1, which is not greater than 1. My series converges, and if they were to ask, how? Conditionally. Remember, these two say it converges. If they were to ask me, find the convergent ones. Yeah, it converges. It's fine. It has an alternator. It's good. But if they were to ask for more clarification, conditional. Cool? Okay. So does it get any harder? Oops, let me circle my answer. Well, I don't know specifically. Just things are going to change. Like, let's just do it together. In your brains right away, do you absolutely know whether to go for absolute or conditional? Steps 1 and 2 are absolute value. It's not as easy to know him, right? I mean, integral tests, I think we can do him. Maybe some of you are thinking that. I'm kind of doing like an integral test in my head right now, and I'm like, okay, I think I know what's going to happen, but maybe we just need to pick one. What do you guys want to pick? 1 and 2 or absolute value? Okay, so 1 and 2. At least we'll know if it converges, right? We just won't know exactly how. Limit as n goes to infinity of, well, nice thing is, guys, bottom wins no matter what, even though it's gross, right? Now, will 1 over n plus 1 times ln of n plus 1 always be less than or equal to 1 over n ln of n for, remember, check it, n greater than or equal to 2? Yes, because ln of 1 is 0. And so from then on out, all the ln's are positive and increasing. If it was before 1, we'd have some issues. So if n equaled 0, we'd be in some hot water. But ln of everything past 1 will be increasing. So that's getting bigger, and then that's getting bigger, and so that's bigger than, oh, sorry, n. My bad. So what do we know right away? Converges. What if they were to ask how? Yeah, I think integral test. Although,
Oh, that was on the homework and I was like, is this a thing? That's what I remembered. And I'm like, it's like ln.
So it's gonna diverge. It's
Is anybody thinking that comparison, like limit comparison test, was faster than integral test, though?
Wait, but if you made ln of n u, would it cancel out with the n? Because it'd be 1 over n.
an ln of infinity.
Yeah, you guys are thinking, that's exactly what I was doing in my head. It's ln of, yeah. But hold on, wait. I'm comparing to, hold on real quick, because some of you just got the feel for a limit comparison test. Couldn't I compare to 1 over n? Which diverges, but wait, those would reduce, and then isn't my limit 0? Bottom wins. 0 with a divergent. Do I know anything?
Yeah.
No, 0 only works with convergent.
Oh, I'm sorry. Yeah.
What if I was to make it n squared? Okay, he's a convergent. Yay, he's a convergent. Okay, cool. But who's winning?
Oh, gotcha.
What if I was to compare to 1 over n squared? Because now he's converging. He's converging. True. I mean, well, we flipped him. But isn't n times n, isn't n greater than ln of n? Doesn't top win infinity? Ugh, infinity convergent. It doesn't mean anything. You could keep on looking for limit comparisons. Just sometimes limit comparisons not easy either. So you could keep looking for limit comparisons. But integral tests, some people have already pointed out that you guys have seen this one before and it was possible. So I'm going there. N equals 2 to infinity of 1 over n ln of n. Remember, we're going to let f of x equal 1 over x ln of x. Is this always positive? Yes. Everything past 1. Is it continuous? Yes, because it's vertical asymptote. Ln of n isn't in there. There's no n equals 0. Is it decreasing? We just talked about that. Yeah. So therefore, if we take the integral from 2 to infinity of 1 over x ln of x. Hopefully you guys would have done u sub with ln of x. du is equal to 1 over x dx. If you multiply up, those cancel. You end up with the integral of 1 over u du. Limit as b goes to infinity. If we were to technically write this correctly, we'd have to do something like this without going to u bounds, because we're keeping it definite without messing up our bounds and our notation. Anyway, long story short, we get ln. Yes, you can, because then they can't judge you or grade you based on what you have. But the problem is, I don't know.
And I just crossed it out.
You could get to the solution. I just wouldn't write the limit, because there's no b if you don't write bounds. Does that make sense? So I would put like the little parentheses for u anti-deriving, and then getting back to your ln of x. Now I can do my 2 and my b and my limit, and I'm appropriate. So hold on. You guys don't want to write this. I get it. Hold on. Pause. Pause. Something like that. So then you're not specifically solving this problem. You're not specifically saying equals, because a definite can't equal an indefinite, if that makes sense. But you're doing the work that you need to get to where you want to go. I guess that works. If you can do it in your head, you're fine. I'm more worried about you writing an equals when it's not really, and then they take away points. Sorry, this is for someone. Okay. Equals ln of b minus ln of 2. Limit as careful, you might lose points. Equals infinity. Whew! So what does my series do? No, you were right. Converges conditionally. I was just filling in the diverge first. There we go. Is that okay? But pause. Does this converge? Would it be counted in the convergent of the 1, 2, and 3 on the multiple choice? Yeah, he converges just because of the alternator. But yeah, he converges. He's an American. Well, whatever. Number 9. Why am I not going to do steps 1 and 2? Because right away I can say, oh, wait a minute, hey, absolute value, 1 over 2 to the n converges by geoseries, because r is equal to what? Yeah, not p series. Such a struggle. No. Right? Struggle. So what am I going to say? my series, no, not diverges. I just looked at the absolute value of this guy and realized he converges. So the alternator would only help the convergence that's already there. So what do I know? The series converges. Absolutely. Does he converge? Yeah, he converges. Does he meet steps 1 and 2? Yeah, he meets steps 1 and 2, and he meets the whole absolute convergence deal. Are we okay? Oh, come on, we're doing it together. You don't have to do it alone. Yeah. Right? Okay, it's all right. We got this. So coming back. Let's start plugging in stuff. Zero. Starting at 1. Equals. Starting at 1. 1's odd, right? So plugging in 1, we get 4 over 2, which is 2. Plus, n is 2. Plug in 2. I get negative 2 over 2, which is negative 1. Plus, n is 3. N is odd. 4 over 4. Plus, plug in 4. 4 is even, negative 1/2. Plus, plug in 5, that'd be 4/6. Plus, plug in 6, that would be negative 2/6.
Okay, this is good. We got it.
Do we see a pattern?
Yeah. It's decreasing.
No?
It's just saying it's negative.
4 over 2, 4 over 4, 4 over 6, 4 over 8, 4 over 10, 4 over 12. What's the other? Every other one doing negative 1, negative 1/2, negative 1/3, negative 1/4, negative 1/5. It's alternating. It's alternating. Well, I'm peeking at it. Are you guys peeking at it? Does anybody see how?
Oh my gosh, 1, 1/2, 1/3.
Oh my. Did they make
That's so annoying.
this really complicated?
So you can't just combine them.
In this one? I was like, well, I guess I could think of alternating and try to figure it out. But wait, pause. Hold on, wait a minute. I'm just about to disprove what is clearly proven. Hold on, give me a sec. What's clearly proven? Like, if this is this, then what? Oh. Series diverges. P series. That P equals 1? Well, no, but yours does, so whatever. So P series, P equals 1, which is not greater than 1. Done. But it was alternating, wasn't it? The negative 1 to the n shows alternating, but alternating can be shown in different ways. One way is, well, it was alternating. Now hold on. But if the series diverges, question, where does the alternating break down? Because steps 1 and 2, well, hold on, steps 1 and 2, something has to fail, right? For the alternator to fail, steps 1 and 2, something has to fail. So what failed?
Well, I guess the thing that's bigger. As we comparison.
You see it? Were the signs alternating? No, but like the overall series, were the signs alternating?
Yes.
Yes. So this is an alternating series. Step 1 would say, what is the limit of the terms? What are they all eventually doing in a haphazard way? Isn't the limit of that 0 and the limit of that 0? So somehow put them together, they're going to 0. So condition 1 is met, true. But what fails? Condition 2 says the terms have to either be less than or equal to. So do I mind, remember, ignoring the positive negative, do I mind the 1 to the 1? No. They can be less than or equal to. But what do I mind? The 1/2 to the 2/3, I'm going to mind a lot. And then the 1/3 to the What would be next? The 1/3 to the 1/2, I'm going to mind a lot. So what fails? Condition 2 of the alternating series. So you could have done alternating series tests and been like, uh-oh, sometimes, well, he's going to keep increasing at parts and decreasing other parts. He's not strictly decreasing. Does that make sense? So the alternating series would say diverge, but it looks like it's kind of convergent. Hey, they're both going to 0, and they're alternating, and they're always less than decreasing. No, they're not. They're not always decreasing. Alternating series fails, but also seeing that he's actually a whole other sequence, series entirely could also tell you that the series diverges. So what do you think I'm going to tell you to do on number 11? Do you remember how I told you to start writing the first terms no matter what? Do we really have to do it every single time? We haven't done it at all this entire lesson, but do you sometimes need to write the terms? Yeah, so can you guys write the terms for me? And let me give you a chance. I did it last time. You do it this time. Practice with the whole weird piecewise-y thing. Practice with the whole weird piecewise-y thing. It's a white slip. Are we scared of white slips now? Oh, okay. I did have a Saturday school come in today. It was very sad. Mr. Huff hand-delivered it. And oh, does he? I didn't notice today. I didn't see the name. Well, you know why. He's establishing a presence on campus. And you guys know his presence. It's here, right? It's okay. I'm just seeing if you can write it out. So I'm going to start writing it out too. There's different ways of making sense. This one happened to go down to a certain series that we knew. Keep on doing that. This one might not. Starting at 1?
4 squared is 16.
Oh, sorry. 1, 2, 3. Man. Yeah. Yep. 1, 2, 3. Two squared, 4 squared, 6 squared, 8 squared. Could we maybe try to get common denominators? 3/4 and... Right. It's not always a good idea. No. Literally, it's not always a good idea. That one worked real well. Like, oh, I can, ooh. Like, I started seeing a pattern. Yeah, I know. But if I kept going, I saw a pattern. I was like, oh, I like patterns. This one, But wait. Uh-oh. Can't we just... It's an alternator, right? It's an alternator. What's the limit of the terms? No matter which one you're on, odd or even, what are the limits of all my terms? They're both going to 0, so that's fine. Yeah, they are going to 0, but what's not fine? They're not strictly decreasing. See the 1/4 to the 1/3? See the 1/16 to the 1/5? See the 1/36 to the 1/7? They're not strictly decreasing. So the alternator fails. That would have been enough up here. I just saw a cool pattern and I went with it. That would have been enough. Series diverges.
So how do you say this since the second condition?
As long as you state the second condition, you don't actually have to put that into words. You're like, a sub n plus 1 is not less than or equal to a sub n. Alternating series says diverge.
Oh, wait, what? If you show it, you don't have to write it out.
It's like the definition of continuous. Remember how we used to have those problems where it's like show by the definition of continuous? So we can go ahead and say like, hey, f of c exists, limit as x approaches c exists, but they don't equal each other. Therefore, by the definition, not continuous. You don't have to say like, because condition 2 fails. You're like, no, I showed it. Condition 2 fails. Does that make sense? Yeah, so showing the math. This isn't like a sign chart where we had this little trick of how to set it up and like, I need to put it into words. This is, no. I said the statement and I showed, I'm saying it fails and that's enough.
And writing it just like that with the 8.
Yeah. Well, because in my head, I like having what it should be and doing a slash. Kind of like P series. I like showing it should be greater than 1 slash. It's fewer things to memorize that way. Okay, so this whole thing, You can read it, you can see it. There's a lot of good stuff in here. The long story short of it is, hold on. Basically, how the alternating series test shows divergence. That's basically what's going on. Maybe we'll talk about it because it shows like a little funky thing that can happen. But I do need to get you guys to write down endeavor number, before you leave today. Or you can take a picture of it, totally fine. Endeavor number 23?
Yeah, no, 22.
I was close. Endeavor number 22. The alternating series estimation theorem. Basically what this is saying is, okay, given an alternating series that converges, absolutely conditionally, we don't care. There is something that can be said about the truncation error. If we truncate, if we cut off the series and only take so many terms, how close is it to the actual? We can't say what the actual is unless it's geometric or it's telescoping. But we can show how accurate an estimation is for alternating series. We can show how close the estimation is for alternating series, and this theorem kind of tells us about that. As you guys are taking a picture of it or writing it down, n plus 1, the n plus first term. R stands for remainder, S stands for actual, nth partial sums stands for the estimated or the truncated, so many n terms, and then that's your n plus 1th term. We'll have to finish this up just a little bit tomorrow, but guys, you can do the majority of homework up until it starts talking about remainder, error, something like that, and you're allowed to stop there. Is that cool? All right, good job, guys. We got a lot of work done, I think, on this one. Yeah, go ahead and turn in pictures. I'm going to put a note as to what problem you can stop at.